Alright, hell yeah. So we have dynamics. And then we have this problem with a stick on a step, and then it's moving this way with a constant velocity. And so this point is going to travel maybe this way and then up. And so what we did is we're going to set it up with this foam board. And actually I already set it up. So this dimension is 2 feet up to there. We have it nice and square. And then we just measure out to 48 inches. And that's going to be our first point. And so what we're going to do is actually do the problem in reverse. You know what I mean? So we're going to come in here and then hit a point there, and then we're going to come out here and hit a point there. So each of these points are going to be like a change in time. So for this point, we have a change in 1/10 of a second. So in 1/10 of a second, that ruler is going to move. That point B that was there is going to be right there. And then if we look at our graph paper, this line, this is the line where the ruler was. So that was the other thing. I definitely marked a line where this is the actual line that the ruler was initially pointed. And what they want is the acceleration in relative to this line. So obviously you can see that the velocity is going that way because here's the next position. So the velocity is always going to be in the direction of the next position. Now the acceleration gets a little bit tricky because if we come down here, here's our initial point. But heck yeah, this point was just a little bit higher. So we do have, well, one, we have a component of the velocity in that direction. Just a little bit, you know what I mean? And but you need 2 points, so you can see over here we were up here, so this velocity vector was going down prior, so we actually kind of move into this point B and then actually move up and out. So we are going to have a change in velocity. Definitely anytime you have a change in direction, hell yeah, that's going to be a change in velocity. So and that's going to give you an acceleration. Alright, hell yeah, I gotta jump in here because this next part I messed up. So measuring this, we had a distance of 53.1 to get to this point, and then from here to there we have a shorter distance. So we traveled faster and then we traveled slower in this direction, and so we're going to have an acceleration going that direction. Hell yeah. Alright, hell yeah. So we're going to do a little shorter video because I just kind of want to go over how, you know, this should be a fairly fast process, even though I can spend way too long setting up these. But at the end of the day, you're just trying to get 3 different points, and we did it. You know what I mean? We got these 2 points, and we have a difference of 53.1 and 52.6 in, you know, in this direction, and then and then so let's get these points. So this is, maybe we'll slow down. This point is 0, 0, and if we go over here, we're going to go negative. So this point is negative 53.1 and 1.4. So you would write it like this, negative 53.1 and then 1.7. You would also write it like this. Like you would say, I'm going to call this point B negative, so that's kind of what we have up here. I'm going to say this is negative 53.1 I hat, because I've set my direction. I'm saying down this grid is going to be I hat, and right here is J hat. And so that was kind of a special part about this problem, is they wanted you to find the velocity and acceleration along this coordinate system. So if I'm calling this I hat and the J hat, basically this is the x-axis and this is the y-axis. You know what I mean? So if you were to use this axis, you might want to call this like x prime, y prime. And sometimes you would do the opposite. You would set for sure just this to be your x, y. But if you wanted, you know, to find something along a different axis, you would call this like the prime axis. But all right, hell yeah. So we're going to get those points, and we're going to have negative 53.1 I and then plus 1.7 J. Okay, so that's that point. This point is 0.00. So when you find, so all velocity is just the change in this position. I'm just going to call it B, change in t. Typically it would be like, hey, velocity is change in x, change in t, you know what I mean? But don't forget about the y-axis. Velocity is also change in y, change in t. So we're kind of separating these two. So when we do our vector, we're going to say, hey, this is change in x, change in t I hat, plus change in y, change in t j hat. So Hell yeah. All right, and then the other thing not to forget about, when you do the change, you have to take the point in the future minus the point that came earlier. So in this problem, it's kind of bizarre because here is our 0, 0, but I'm saying, hey, let's take this system, you know what I mean, before this happened, before it got to this point, and then we're going to find that, and that's what we did. And then we come to this point. So we have the earliest point is this, the next point is this, and the next point is this. So to find the change in position, you go to the future point minus this. So this is going to be, you know what I mean, 0 minus negative 53.1. And then the other aspect, yeah, so then to that point is now going to be, that's when I was just like, damn it, you know what I mean, maybe we'll have to go a little bit slower on this, because I got all these values in millimeters, but the problem really wants velocity and acceleration. It wants velocity in feet per second, and it wants acceleration in feet per second squared. So we need to convert millimeters to feet. So let's do that. So if we say that this is going to be negative 53.1 millimeters, we use factor label, we go 25.4 millimeters downstairs, 1 inch upstairs. These are equivalent. 1 inch is 25.4 millimeters, 100%. Then we can cancel millimeters. Sweet. And then, so now we'll have this in inches. We don't want it in inches. We need to kind of do the same thing. 12 inches is 1 foot. These are synonymous. 1 foot, hell yeah, is 12 inches. But we need to cancel the units, you know what I mean, just like that, just like so. And now we're into feet. So then we can say negative 53.1 divided by 25.4 divided by 12. And that's where we get this. So this is our point for B, and then if we did the same thing. So I did those for all of our points. We have point A, we have like the minus. I'm calling what happened before this 0, 0 point minus. B naught is the 0, 0, like location, and then positive. And our change in time on this is 0.1 seconds. Alright, hell yeah. So again, let's just kind of do it mentally. To find the velocity between this negative and then this B naught, you're going to take the one in the future. So you're going to go 0 minus a negative 0.174. So that means that we're going to get a velocity that's a positive 1.74. And then just go back to our picture. Does that make sense? We were right here, and then we ended up there. It looks like we had a velocity in that direction, and that is the positive. This is the positive I, this is the positive J. Alright, hell yeah. And then you kind of do that with the same. You know, these were very small, but this was 1.7 millimeters up, and then we went down. So this velocity should be a negative, and I even kind of almost ruined it, but hell yeah, negative 0.055. And then we'll do the same thing here. So this point should have a velocity positive, and then, where's our point? I can't even tell where our points are. They should be, oh, right there. So positive, and then we go up 1.2 millimeters. So we just go up a millimeter, like hardly anything. But we're going to have a velocity in that positive direction. So that's going to be this guy. Hell yeah. So now we have two different velocities, and then what I did is average these two. So if we take 1.7 plus 1.7 divided by 2, you're basically going to get 1.7. So that's where our average velocity. This is for our other 2 points. That's why I'm doing the subscript 2. But for this one, yeah, hell yeah. Our velocity is 1.7 feet per second. Nice. But then in that direction. In this direction, when we take a negative and then add it to this positive, you know what I mean, and then divided by 2, these are going to kind of cancel-ish each other out, and we don't get, like, you know, this should be screaming like, whoa, this is very low. It looks like this is like 0, you know what I mean? And, you know what I mean? So that's kind of what we have there. Alright, hell yeah. Okay, but just because the velocity is 0 at point B doesn't mean there's not acceleration. Because again, we're having a downward velocity. We're going 1.7 millimeters in 1/10 of a second in this direction. And then from here to here, we're going 1.2 millimeters that direction in 1/10 of a second. Oh, and my bad, my bad. The other thing that I did not go over is that we have to divide by our change in t. So our change in t is 0.1. So what I was doing was just finding the change in position. That's going to be 0 minus negative 0.17. So that's going to give us positive 0.17, but then we got to divide it by 0.1 seconds for this equation, and that's where we get 1.7. So hell yeah. And obviously, like, this problem says this is traveling 2 feet per second. In millimeter world, like, oh damn it, 4 inches, so that's going to be 2 divided by 3, 2 times 3, that's going to be 6 4 inches, and then we're going to have 100, this is 6, yeah, it's so hard for me to do conversions, but yeah, this is 600 millimeters. So we're basically traveling 600 millimeters in a second. Hey, divide by 10. Hey, we're going to be traveling about 60 millimeters in a second, in a tenth of a second. And that's what our problem says. Hell yeah, we went 53 millimeters and then 52.6. And in those directions, while this one went, you know, basically 60 millimeters. And so hell yeah, so we got to check on reality there. But because of that, hey, we went 60 millimeters in a tenth of a second, but our units on velocity is going to be, you know what I mean, millimeters per second. You know, our units aren't millimeters per tenth of a second or feet per tenth of a second. So that's where, if we take this small representative sample of a change in time of a tenth of a second, hell yeah, in a tenth of a second, we're going to be going that far. But in a full second, we're going to be going 10 times this. You know what I mean? So now you kind of see that, hell yeah, we go about 6 inches. You know what I mean? In a second. All right, booyah. So just to point that out. What we do is we take the difference in position and then divide by that 0.1. And that kind of increases that number. Same thing. Once we get the two velocities, we do the same thing. We take the difference between these two velocities. Look at this. There's not much difference here. But then we take that number and then divide by 0.1. That's kind of like multiplying by 10 and to get the acceleration. And the other thing about this was a faster speed coming in because this number is bigger. This was a slower speed going out because this number is slower. So the only way our acceleration is going to be going that way. Our change in velocity, we have a lot of velocity this way, but then when we get to here, we don't keep that lot of velocity. We must have had a change in velocity in that direction. And so that's going to be the negative direction, and that's what we see. And it's small, but it is something. So how to do that? Let's just do it with our calculators. 1.726 minus 1.7421. And then divided by that change in time. And that's going to be 0.1. And then so we're going to get negative 0.1640. I don't know why those aren't coming out 100%, but these were stored in my calculator at the time, so maybe I wrote them a little bit wrong. But hell yeah. And then even right here, let's do another one. 0.03937 minus a negative 0.05577. And then divide by 0.1. Okay, hell yeah. So this is 0.9514. So that came out 100%. Okay, and that was the thing. We noticed most of the acceleration change. Well, maybe not most, but we definitely knew that we were going this direction and then going this direction. So that should scream like change in velocity. You know, anytime that you're going this direction and then switching directions, well, hell yeah, you must have like at least changed your velocity to 0 and then got it going, you know what I mean, the other direction. All right, hell yeah. So heck yeah, we did it. So we got that acceleration of 0.9514. But these were just off 2 points. So this is going to be my take-home message. This wasn't a slow video. This wasn't a fast video. But when you do this 3-point method, I'm finding that having, because look at this, like the change in this direction, 1.7 to 1.2, I can't even measure that very well with my eyeballs. And so I could be horribly off. And that small amount is going to drive this acceleration number. You know what I mean? And so the take-home point is like, hey, also get something a little bit farther away, especially if your changes are very small. If you notice your changes are hella small, yeah, definitely try to get farther away, because like right here, we had a better change in, yeah, I don't even have them written in, but like that one's up to there and that one's up to there. So heck yeah, this might be a millimeter of change, probably not, but we got a better, having points farther away, you get kind of more accurate when it comes to those changes in velocity and again those changes in acceleration, because the errors compound, you know, if your measurements aren't really accurate. Okay, hell yeah. So and then the only other thing was that these points, I couldn't just go to I was doing increments of 0.1 seconds. So this was 0.1 seconds. I couldn't just do a full second. That would have been way out here. So I just on my ruler measured this distance, and it was like 138.7 millimeters. And then so let's take a look at this. All right, so I just brought this point to here at 138.7 millimeters, and then brought it to here, that same thing. So here's my point before and then my point after, and it's this same distance away. How long did that take? You know, if we have a speed of 2 feet per second, so I'm going to take that 138.7 millimeters, we're going to convert it to inches, convert it to feet, and then I'm going to divide by this 2 feet per second. And hell yeah, feet's cancel, this second pops upstairs, and so we get 0.2275 seconds, and that's what we'd expect. If we got here in a tenth of a second, well, we're going to get, so here in a tenth of a second, I'm going to get here in, yeah, a little over 0.2 seconds, 2/10. So, and then that's going to be our change in time. And so, so we have 122 millimeters. Yeah, let's, this video is no longer short, so let's do this. So we have 122 divided by 25.4 divided by 12. This gets us into feet. And then so in my calculator, hell yeah, I'm going to store that position as A. I forgot to make it negative, so we're going to go negative second answer. I'm going to store it as alpha A. Booyah, we got that in there. So now over here, this is 118. So we got 118 divided by 25.4 divided by 12. And then we're just set there. I'm going to store that as alpha B. No. This is the positive one. So this would be alpha C. I'm sorry. I should have done them in sets. So let's go back to here. So this point is negative 122 millimeters this way, and then up 6.2. So we're going to take that 6.2 divided by 25.4 divided by 12, store that as alpha B. Hell yeah. And then this point right here, oh, it's 7.3 millimeters. So yes, there was a full millimeter difference, 6.2 to 7.3. So, and that's really going to help our acceleration. And I guess just to spell it out, the acceleration, we're gonna end up getting this value and this value. And the actual answer is negative 0.25 and 0.866, just like the sine of 60. So we got 0.8556. So hell yeah, we were way better taking points farther away than we were taking points closer in. This was 0.95. Now it gets you in the ballpark and in the right direction. You know what I mean? So you can't complain, because some of these problems, it's like you just kind of want to feel what's happening, because maybe something magical is happening. You never know. All right, so so we have point A, B, hell yeah, and I think we have point C. Whoa. Oh yeah. So point A, point A, point C. Yeah, so we have those. And now we just need this 7.3. 7.3 divided by 25.4 divided by 12, stored as alpha D. Oof, alpha D. Okay, hell yeah. And then I do need to store this alpha T. This time of 0.2275 seconds is in my calculator as alpha T. So now we can figure out the velocity. It's going to be 0 minus, well, is alpha A negative? Hell yeah. So it's going to be 0 minus this position, alpha A, and then we're going to divide by that change in time. And hell yeah, we're going to get 1.759. So, yeah, booyah. And I'm going to store that as alpha E. Cool. Now we're going to do, we're going to find this one. We're going to go 0 minus alpha B divided by alpha T. Cool. And we're going to get negative, store that as alpha F. Cool, and so we just got that. So this is the velocity before. We have a downward and an over. So that's what we're seeing. We're seeing this over and then this down. All right, so now to get this the velocity from here to here, we're going to take the difference between alpha C minus 0 divided by alpha T. And I'm going to store that as alpha G. And then we're going to have this alpha D minus 0, which is just alpha D divided by alpha T. So alpha D divided by alpha T. And we're going to store that as alpha H. Okay, hell yeah. So alpha G, alpha H, and that's going to be our velocity components here. So the acceleration is just alpha G minus alpha E divided by... The acceleration, definitionally, is the change in velocity divided by the change in time. So we still have that same change in time. And we're going to get negative 0.2535. So hell yeah. We're going to do the difference in the velocities. 8 alpha H minus alpha F divided by change in T. Okay, now we get, I don't know why I wrecked that. Holy hell. Alpha H minus alpha F divided by alpha T. Bummer. Alpha H is, so alpha H is wrong alpha F. That one's probably pretty close. I have a mistake here, so, well, let's just, you know what I mean, not get too upset. So it's this term, it's this 7.3. 7.3 divided by 25.4 divided by 12. That should be... and it's in the positive direction for D, so alpha D should be... No, so alpha D was messed up. Stored as alpha D. Okay, and so we have alpha D minus alpha B divided by alpha T. This is going to get us the velocity equation for this, alpha H. Whoa. Stored as alpha H. And now let's see if we're good. Alpha H minus alpha F divided by alpha T. Okay, so now we're messed up. Oh, this is a bummer. Alright, so, yeah, this is good. This is good, because, like, typically sometimes when you're, like, messed up, you're like, oh, shoot, do I just need to do the whole thing through? But I've been trying this new technique of, like, kind of working backwards. So we're trying to find the acceleration, which is the difference between these two velocities, which is the difference between this position and this position, and this position and this position. Okay, hell yeah. So this, and maybe, you know, so let's get this point. So we got 6.2 divided by 25.4. This is in inches divided by 12. This is in feet. And I'm just going to double check. Alpha B. All right, so we were good there. And now we're going to go 0 minus alpha B divided by alpha T. And that should be this alpha F. And it is, so we're good there. Okay, now let's take the change in position here. So we got 7.3 divided by 25.4 divided by 12. And then that should be alpha D. It is. And now we're going to take alpha D minus 0 divided by alpha T. Cool, and that's going to be this alpha, this alpha H. So alpha H, and yeah, this was wrong. So I don't know where we got off. So there you go. So store that as alpha H, and now we should be good to go. So we're going to do, if these are our two velocity equations, and we want to find the acceleration in this J direction, you know what I mean, this downward and upward thing, then we're going to take the change in velocity, H minus F, and then divide by that change in T. Hell yeah. And then we get that 0.8556. So that was a good strategy of like, hey, when you run into an issue, like like, man, I have a tendency just to just like throw the problem away, go all the way to the back. But no, it's just like, well, what was the last thing you worked on? And then, like, see how I even said, hey, we're just working in these J directions. So none of that answer is going to be affected by the X direction. So I just went all the way back to the positions of the J, and that was fine. I wanted to go all the way back that far. I tried just to see if I could figure it out. Couldn't, went back to there, and then we got the right answer. But hell yeah. So these two positions being farther away are going to give us a better answer. The other thing for velocity now, we have the velocity coming in and the velocity going out. But what the question asks is like, hey, what's the velocity right at that point? So we're going to, this is alpha E. So alpha E, alpha F, just to show you all these values, alpha G, and then alpha H. Okay, so we have 1.759 coming in, and then leaving is in that direction is 1.7. Okay. And then we have negative coming in and then positive going out. So what's the average between those? You know, like I said, those are going to cancel out maybe. But the average between 1.7 this way and then 1.7 this way, adding those up, dividing by 2 is the same number that way. Okay, so I just wanted to show that. And then, but to find the average, it's a different equation. You basically add them and then divide by 2. And does that make sense? If I have the number 1 and the number 3, how do I find like the midpoint between these? I add them. 1 plus 3 divide by 2. That's going to be 4 divided by 2. That's going to be 2. That'll get you the midpoint every time. You know what I mean? Because let's say I have 3 and 4. What's the midpoint? It's going to be 3 plus 4 is 7. 7 divided by 2 is 3.5. Hell yeah. And that small equation, you know, I probably graduated without fully understanding that one. So I definitely speak up about that all the time. You know, that's such a cool one. Try to use that on the daily. All right, hell, what are we going to do? We're going to use that equation. All right, so we have alpha E plus alpha G divided by 2. And so that's where we get this average velocity, 1.7304. And then we're going to alpha F plus alpha H divide by 2. And these are going to kind of cancel out. So we're going to get 0.008, and I just called it. And like I said, hey, this is pretty close to 0. You know what I mean? And as you get a better representation of this problem, hell yeah, this thing gets real small. Where, and then let's see our change. Like, you know, between these points, we got 0.08, you know, and I don't know if this should be a negative. That would be weird if, yeah, like, oh no, yeah, let's do this. This is fascinating me. Because initially, we had 1.7 millimeters here, and then 1.2. So our change, this is going to be a negative velocity. So we basically have a negative velocity in that direction is what we saw. But then when we went over here, we have a 7.3 over here and 6.2. So we're actually going to have a positive velocity. So that just really shows this number is so small and so hard to calculate that it was just really weird that I came up with a positive 0.008 and a negative 0.008. And that would have thrown me for a loop. So this is really cool. It's essentially just 0. This number could have been anything. But I don't know if that's it's not representative of our accuracy because, you know, well, maybe it kind of is. But yeah, basically that number is probably a big goose egg on the velocity at that point. Alright, hell yeah, I think we did it. So this was the 3-point method, and I'm pretty satisfied with the video. And so thanks for joining me on this. You know, anytime you have a ladder that's kind of moving, this angle, you know. Oh, and then should we kind of polish this one off? You know, because I never did find, it said also find the angular velocity of the bar. And you know what? We can't do that for this problem because this whole thing was just the 3-point method. This is going to find you velocity and acceleration. You know, never in the setup was I actually interested in finding this angle or the change in angle. So we're going to leave it at that and probably do the angular velocity of this bar as it slides up. You know, that's kind of what it's doing, and we're going to do that in a separate video. So thanks for joining me on this one, and that's the video.